Some of the most productive and yet common types of gold deposits all around the world are those directly related to mountain building events. They're called orogenic or sometimes mesothermal type deposits. The orogenic comes from the term meaning mountain building. But over the last 100 years, this type of gold deposit has been called by a number of different names, including, like I say, mesothermal, mother lode type, because the prime example is the mother lode in California, but they're all over the world. Also, it's been called a low sulfide quartz gold or gold only type veins. And all those different names are part of the confusion. Other names include shear-zone hosted deposits, greenstone belt gold, and slate belt or turbidite hosted gold deposits. So you can see there's been a whole lot of names, but we're going to stick with mesothermal orogenic because those have been two of the most common names that these deposits were known by. And so all these different names that they've been known by geologists, like I say, give rise to confusion to prospectors and even confusion among geologists too. But they're widespread, they're often very rich in grade, and they give rise to some really great placer deposits all over the place. And I will tell you that of all the gold ever mined by humanity, some 3/4 of all the gold ever mined is from this class of deposits. That is, if you include placers that are derived from them, because they generally give some fairly coarse size gold. And, even though it isn't always big nuggets, it gives, decent sized placer flakes and pickers and that kind of stuff too. So do you want to learn about what kind of gold deposit makes up 75% of all the gold ever mined? I'll bet you do. Hey, I'm Chris Ralph, the professional prospector, and today we're talking about these mesothermal / orogenic mountain building event related gold deposits. Now, the mineralized veins that make up these gold deposits, we're going to talk about what the ores look like. The mineralized veins that make up these gold deposits are mostly quartz with subordinate amounts of carbonates like calcite and, of course, sulfides like pyrite or galena, arsenopyrite, and a few others. The veins generally contain no more than about 2 or 3% sulfides, and very commonly the bulk of the sulfides is pyrite. There's usually also a zoned envelope of alteration around the veins, although the alteration zone may only be, from a few feet to tens of feet wide. It's not as big as some of the epithermal veins that have really big halos around them. But still, the halos that are around the mesothermal orogenic types are useful to help trace and find ore deposits. The gold occurs mostly in the quartz vein, but can occur in the adjacent wall rock as well. And usually the gold is closely associated with the sulfide minerals. And in a lot of places where there's no sulfides, there's not much gold either. But there are plenty of exceptions to this rule, and I'll show you at least one good one. The sulfide minerals, like I say, are mostly pyrite, but can include pyrrhotite, chalcopyrite, galena, sphalerite, and of course arsenopyrite, which is actually one of the more common ones. Not all of them have tellurides, but in some of these types of deposits, tellurides are a very important part of the values in the vein. The silver to gold ratio usually is such that the silver may be about the same or may be a little more by weight than the gold, but the value is, because gold is worth so much more than silver, the value is predominantly gold. So you may have 1-to-1, or you may have 3, 4, 5 ounces of silver to 1 ounce of gold, but gold is worth so much more than silver that the value of the gold predominates. The veins are contiguous for long stretches, and very many of them stretch for a mile or even more. And they can stretch for huge depths down dip because, it could be thousands of feet, many thousands of feet, even as deep as 2 miles. Some of the deposits in India are that deep along the vein. And there's generally very little change in grade and tenor of the ore as one moves down dip. They form actually very deep in the earth, and so because they're so deep, there's not a lot of change from top to bottom in the zone that they form in. Often the changes are minor. Even the sulfide minerals and the gangue minerals that are present will remain pretty much the same. Hey, let's take a look at some examples of what these ores look like and why they're so rich in gold, and give you a feel for what you're looking for when you're out in the field.
Here's a typical piece of quartz vein ore. You can see little spots in there. It's hard to tell, but it's actually, those are little spots of gold, little fine flakes and bits in quartz. Not all gold ore has visible gold, but a good percentage or a significant part of it does. Here's a piece of common gold quartz ore. Now, there's no visible gold in this, but it can still have small pieces in there scattered through the quartz, enough that it was worthwhile for commercial mining. But then again, ore that's pretty much barren will not look that much different. But there are times when it has a lot of good, visible, coarse gold in it. And these are some specimens that were picked off an old mine dump. The old miners threw them out, but the metal detector screamed on them and said, "Hey, look, there's gold in this rock." Most of the quartz that has good gold will have either rusty signs that there were sulfides like pyrite, or actual visible sulfides in the rock. But occasionally you do get pieces like this with no sign whatsoever of pyrite, but great gold. Now, I mentioned metal detecting in the old mine dumps outside of the mine, and that is a great place to use your metal detector. But in some cases, you can get inside the mine safely, and this is a spot where I was using my metal detector and actually found a gold-bearing quartz in the unmined part of the vein. Now, this is a shot of the vein. It's not the spot where I was using my metal detector underground, but it is actually the same quartz vein, just in a different part of the mine. And you can see that sometimes there's just amazing amounts of gold right in the wall rock, right in the wall that the miners left off. And if the gold can be removed properly from the vein and then treated to bring out the beauty of the specimen, it can make some really spectacular pieces like this. Don't know if you can see the price, but the listed price for this specimen was $14,500.
Next, let's talk a little bit about the geology of these mesothermal orogenic gold deposits. And we're going to look first at greenstone belts, because the greenstone belts actually are the most important class or subclass of this type of deposit. And they include some really huge deposits, the greenstone belt ones do. Some of them are up to 10 million ounces of gold in size. In the greenstone belt deposits, the quartz carbonate veins that make up these gold deposits are often distributed along series of large regional or otherwise large scale faults. And because there's been movement along these faults, they often bring together different kinds of rock on one side of the fault versus the other. And it's very common that the vein deposits and the otherwise best deposits are located at these contacts. The best deposits are often located at points where the faults make a bend, or you get a bend and then you get splays out from the bend where you have a fault going a certain direction. It takes a bend and there may be a continuous splay going out in the original direction when the main fault takes a bend. In some deposits, especially the splay ones, they're often associated with secondary smaller fault structures as well. Some of the larger districts and deposits are associated with a later conglomerate type of deposit, as exemplified by conglomerates in the Abitibi district in Canada, and then also the Birimian Shield district in Ghana and other parts of West Africa. At the actual local scale of formation of an individual deposit, it often depends on the nature of the fault that's gone through there, as well as the adjoining rock types. They have to be favorable in order to form the deposit. Where you have strong and competent rock units adjoining to rocks that are easily fractured and broken, that gives you a tendency to open up a space for the mineralizing fluids to come in and deposit quartz veins and gold. Many times these include metamorphic rocks that have been altered by heat and pressure, like basalt, which when it's altered by heat and pressure is sometimes called greenstone. And that's how you get the name greenstone belt. Let's take a look at some diagrams to better understand the greenstone belt class of these deposits.
So here's a diagram that kind of shows how these greenstone belts are formed at intersections where two plates are coming together and one is going down below the other. But one of the things I want you to note in this is on the far right, the depth. These are, more than 10, 20, maybe even 25 kilometers deep. So we're talking 6 up to maybe 15 miles deep when they form. And that's how they get to be formed at such great depth. This diagram shows what it's like after the material that's been formed so deep is uplifted and also surrounded by other rocks, granites usually, but could be other things. And you see the greenstone forms a line, and the lines may branch off and stuff, but that is why they get called a greenstone belt, because there is a narrow line of this type of special rock. Here are 4 pieces of greenstone that all look very much the same, but they're from very different places. The 2 on the left, the upper left is from West Africa, the lower left is from Australia, Western Australia. The 2 on the right, the upper right is from the Mother Lode country of California, and the lower right is from Gold Country in Arizona. I found gold in the general vicinity of all 4 of these specimens, and so they're closely associated with gold, but this is what the greenstone looks like when it's not weathered. But the problem is this rock weathers fairly easily, and once weathered, it doesn't really look the same. This is the same greenstone as the 4 rocks I just showed you, but it's been deeply weathered and oxidized, and a lot of the iron in the rock converted to rusty iron oxides, and so it looks very different. This is actually a gold digging area in West Africa, and there was good gold produced here, and all the rock that's in that picture is greenstone. But it's very weathered, and so it just doesn't look anything like the 4 rocks that I showed you a minute ago. If you took some of the bigger pieces and broke them open, it might look more like those 4 pieces. But the greenstone belts do produce some very nice gold. This is some gold specimens from greenstone belts in eastern Canada.
Next, let's take a look at the slate belt or turbidite hosted deposit. This is another class of these mesothermal orogenic type deposits. These slate belt hosted deposits are common in many parts of the world and sometimes are very rich. Deposits of this type often occur in thick graywacke or mudstone type sequences that have been changed by metamorphic heat and pressure into rocks like slate, phyllite, or schist. Dikes and sills of mafic or volcanic rocks sometimes are closely associated with these deposits. They can be intruded by granitic bodies of molten rock and are found commonly near major crustal or tectonic type boundaries. They're commonly found at the contact of mafic rocks or ultra-basic rocks like serpentine, and then metamorphic mudstones like slates or phyllite. The mineralization style varies from, of course, straight veins to various stockworks and breccias and even disseminated deposits. The most common type are the quartz veins, the simple quartz veins hosted by reverse faults. Different types of veins are recognized, different types of ores, but the most common is milky white to slightly smoky quartz with some calcite and minor amounts of sulfides, like I say, pyrite or arsenopyrite. The sulfides can also be disseminated into the adjoining wall rocks, and where there's enough of that kind of dissemination, you can actually create a large-scale ore body for low-grade rock that could be mined like open pit, something like that. Let's take a look at some diagrams to better understand these slate belt or turbidite type hosted deposits.
These slate belt deposits are some of the richest deposits in the world and are home to very large areas of gold-bearing deposits that are spread throughout them. This is the area that's the Golden Triangle in Victoria State in Australia. Another of the most famous slate belt gold-type deposits is the Mother Lode country in California. This map shows the slate belts in blue and then serpentine and intrusive rock in green. And you can see the dark black lines that are associated with the slate belts. Those are the zones, the fault zones that can carry the gold deposits. So the gold deposits parallel the slate belt and in fact run through it.
Finally, the third class of these deposits is the banded iron formation, and one of the very largest deposits in the whole United States belongs to this class, and that's the Homestake mine in the Black Hills of South Dakota. The deposits consist mainly of replacement by magnetite or other minerals of various bands in these banded iron formations, including some of the silicate bands, and they're normally adjacent to quartz veins that are hosted in faults. The most intensely mineralized consist of almost continuous wall rock replacement. These banded iron formation deposits occur in specific types of greenstone belts that are either volcanic rock or sedimentary rock dominated, but often in an area where there's some regional transition between the two, as in the case of Homestake and Morro Velho in Brazil. Like some of the other deposits of this class, the banded iron formations, the best deposits, are often associated with bends in fault zones, folds, and other shear zone where faults step over and you get a shear zone, a fault zone breaks up and splays out. As a result, the deposits are often strata bound and dip parallel to the controlling shear zone that formed it. Let's take a look at some diagrams and other things to better understand the banded iron formation.
This is what these banded iron formations look like. Sometimes the lines are flat and straight, sometimes like this, they're twisted and folded and bent, but it's a similar idea. The actual red lines are iron-rich silicates, jasper and sort of thing, and the dark gray lines are the iron-rich zones in the rock. And actually, banded iron formations are worldwide a major source of iron ore, and more than they are a source of gold ore, even though they can host some really great gold deposits. They are a normal source of iron ore in many areas. In fact, I know a guy in Australia who staked some claims for the gold that was there, but the gold wasn't that great. But it just turns out that he had a lot of banded iron, and the mining company bought the claims out for a lot of money, not because of the gold that was there, but because of the iron that was there. Here's a photograph of a natural outcrop of this type of material, a picture I took in Australia, and there's bits of this all over the place. And the white rocks that you see on the edges there are quartz, and yes, there was some gold in this general area. And yes, these deposits can produce some super high-grade ore. This is a specimen of quartz vein material from the Homestake mine in North Dakota, and it certainly shows a lot of gold and explains why this mine was a huge producer. In fact, it's one of the largest producers in the United States of gold.
Let's talk next about placer deposits. The erosion of these orogenic or mesothermal types of deposits have created some of the richest gold placers that have ever been mined by mankind. In almost all areas where these these types of quartz veins are exposed, there is some type of placer that's derived from them where there's been any kind of erosion at all. In many cases, the bulk of the gold eroded out of the veins, at least a large portion of it, remains in the area in rivers and streams as these placer deposits. In areas where the erosion is deep and the gradients along the streams are favorable, they can form supremely rich placers, and have in many places. In California, the gold placers were, the Mother Lode country, the gold placers were about 40% of the total gold that was taken. In California, these include both older tertiary channel type deposits, but also younger modern gravels of streams and benches along the current drainage. Examples of deep erosion and the formation of some really great placer deposits include, of course, the Mother Lode country in Sierra Nevada, the Klamath Mountains, and that area in both northwestern California and southwestern Oregon. Also, the southeast part of Alaska, the Seward Peninsula area, including the Treadwell mines and the placers around that area. The famous placers of West Africa and also of Australia are mostly of this type as well. The deep weathering of these types of veins in tropical regions can produce lateritic types of placer deposits. Let's take a look at some of the placers that come from these rich orogenic type gold deposits.
Here's a group of nuggets that are from the northern part of the California Mother Lode country. And you can see these things are huge. These are all 5, 10, 20 ounce nuggets, and some even larger than that. The area does produce some really nice big gold. And it's not just one mine or one place, one district. This is a 7.5 ounce nugget that a friend of mine found while dredging back when it was still legal in California in a well-known gold-bearing river. It just happened on a really good spot and pulled out this really nice beauty. Here's a really nice 3.5 ounces worth of nuggets that I found for myself with a metal detector in a gold placer area in Northern California, the northern part of the Mother Lode country. Again, it is a type of deposit. The orogenic mesothermal deposits do produce some really nice placer gold. And it's not just the orogenic deposits in California. This is a 13.5 ounce nugget from British Columbia in Canada that also originated in these types of deposits.
Okay, let's look at these mesothermal orogenic deposits in the U.S. Now, the most productive orogenic type of deposits in the United States have been, of course, the Mother Lode country of the Sierra Nevada. The bulk of the Mother Lode country mineralization has been found in a belt of metamorphic rocks that run along the western foothills of the Sierra Nevada and up through the northern part of the Sierra Nevada range. These rocks are complexly faulted and folded and contain a number of different rock types. The principal rock types are slates, phyalites, and schist, together with quartzite, limestone, and hornfells of the Calaveras Formation. They also include the Amador group of metamorphosed volcanic rocks, the Mariposa Formation, which is mostly slate, and the Kernville series of schist, phyalite, and quartzite in the very far southern part of the Sierra Nevada range. There are also numerous intrusions of basic and ultra-basic rocks, a lot of which have been altered to serpentinite, or sometimes just called serpentine in older reports. The main Mother Lode fault zone, also known as the Malones Fault Zone, is the principal regional scale fault that the deposits of the Mother Lode country are associated with. Other important orogenic types of deposit or regions in the U.S. include northwestern California and southwestern Oregon, the Klamath Range and all the deposits that go in that area. Also the the southeastern part of Alaska, which includes the Juneau area, the Treadwell mine, and that sort of stuff. And then finally, but certainly not least, the Black Hills of South Dakota and that area. Let's take a look at a map of some orogenic deposits in the United States.
This map covers the northwestern part of the U.S., and pretty much all the areas marked in blue are the areas with good potential for orogenic gold deposits. And this covers the Sierra Mother Lode country, the Klamath region of Northern California and southwestern Oregon, and then also eastern Oregon, the area there that extends into Idaho. And then way up north in Washington, and of course that extends up into British Columbia. But all of these have great potential for gold deposits of this type. This map shows the extension of these types of deposits northward toward and into Alaska. The kind of brick red colored material is all terrain or ground that's been shoved onto the North American continent by tectonic plate collision. And you can see that quite a bit of North America is material that's been shoved up onto it from these plates sliding under one another. And then the orange color line is lines of intrusive rock, batholith, granitic type rocks that have been intruded and are there because of the plate collisions. And then the yellow gold mines are shown with them and how they correlate with all that. But this shows that these orogenic deposits do indeed extend north into Alaska. This map shows the far southwestern corner of the U.S. with the gold deposits. In the area that's orogenic is shown in yellow, and they extend from far southeastern California through southwestern Arizona into northern Mexico. And it shows how this continues to extend along the coast. Now, this covers the western U.S. pretty well, but you may ask, well, what about other parts of the U.S.? And sure, there are certainly other parts. I know that in Wyoming, there are areas that are thought to have orogenic gold, and in the eastern U.S., the Appalachian areas, it's kind of under debate by geologists. Some think it's epithermal, some think some of the deposits are orogenic, and the high-level debate between geologists as to what deposit is what is really not a kind of a topic I'd cover here on YouTube. So that covers the U.S. pretty well.
Now let's take a look at some worldwide mesothermal orogenic types of gold regions. With very few exceptions, these deposits are formed in and around regions of tectonic plate activity. The plate collisions can cause the mountain building events. So the plates colliding builds up mountains as the plates contact each other. And that's where that name orogenic comes from. Some are located in plate contacts where the actual plate contact is either ongoing or relatively recent, like the Mother Lode region of California, up and down British Columbia on the western edge of British Columbia and then into southeastern Alaska. And some are from older areas, basically incorporated now into continental bodies. These are sometimes called cratons. And an example of this is in Australia, where areas that once were part of active plate collisions are no longer that way, but the gold deposits that were formed in them, long ago are still gold deposits, and they've a lot been eroded, but they're still there to be found. The same is true that cratons for gold deposits in eastern Canada, in Brazil, and of course in the part of West Africa that's gold bearing. The younger ones that I mentioned, California also should be included in that, is the slate belt deposits of New Zealand. Let's take a look at some maps of a worldwide mesothermal type of deposits, the gold deposits associated with them, and talk about that a little more.
Here's a map showing the gold deposits and orogenic deposits of Australia. And there are a few that aren't orogenic in Australia, but the vast majority are. Pretty much all the ones located in various shades of brown or lavender, purple, pink kind of thing. Those are all going to be orogenic type deposits. So the vast majority of the gold from Australia is of that type. And these are older craton type land masses, not the younger type that I talked about. Here's a map of British Columbia showing the orogenic deposits and regions marked in purple. These are not all of them, but they are by far the most important ones known. And the mineralization that is in British Columbia continues on north into Alaska. Of course, there are also famous gold deposits and orogenic deposits in eastern Canada as well, the Abitibi area. It just gets to where there's so many of these things worldwide, I can't show all of them. Here's a map showing a set of orogenic deposits associated with the Andes mountain range in South America. And there's a lot of them here, but one of the things I want to say is that I just can't show a map of every deposit known in the world. There are ones, of course, in Brazil, on the other side of Brazil, in India and other places as well. Of course, West Africa is one of the best known of this type. And so there are so many that you really can't show them all.
Okay, let's talk about what you need to do when you're prospecting for these types of deposits. All across the globe, these types of deposits have a number of similar themes of faults, perhaps when the fault bends, of contacts of different kinds of rock type, of major tectonic action where plates were colliding, of major regional faults that occur because of the plates coming together. And although the different kinds of rock types that are found in these deposits can vary, I mean, there's favorable rock contacts and rock types for a number of different places. So you can't just say, hey, what works in the Mother Lode country is going to work in West Africa, or what works in Australia is going to work in British Columbia, because they're not always exactly the same. The themes are the same. The faulting, the greenstone belts, and you know, like I say, the different rock contacts and that kind of stuff, that stuff remains the same, but the favorable rock types and the exact occurrences, you know, tend to change from place to place. You just have to learn what works in your particular area, or the area that you plan to be prospecting in. And once you know what works in your area, you can look for those particular rock types. Another common rock type that works in a lot of areas, but not necessarily all, is intrusive rocks, igneous intrusive rocks, and then metamorphic coming into contact. Now, sometimes the igneous intrusive rock won't really look like what you expect an igneous intrusive rock if it's been altered. So this includes things like the contact in both the Mother Lode country and also in the Klamath region, where you have a serpentine or serpentinite body coming together with a metamorphic rock. Well, serpentinite is an altered form of rock called peridotite or dunite, which is a ultra basic type of intrusive rock, but it gets altered, and so instead you see the waxy serpentine type of rock. Belts of slate and faults through and contacting the belts of slate are also important in a number of areas. Because these types of veins are comparatively high grade and the gold is comparatively coarse, they actually make pretty good targets for individual prospectors to find and to work, because you can crush them and get the gold out of it because it's not too small, and because the veins are fairly high grade, you don't have to crush a huge amount of rock to get a decent amount of gold. And so over the whole earth, most of the times, or at least most commonly, these types of deposits are worked by underground methods, although there certainly are disseminated stockwork and other types of deposits that are worked by open pit. Now, I've said in a number of my videos that prospecting, whether you're prospecting for mesothermal orogenic gold or some other type of gold deposit or gemstones or whatever, prospecting is a skill, and it's about what you know, because what you know makes all the difference in the world. And in order to help give you the skills to prospect, especially for gold, I wrote a book. It's called Fistful of Gold, and I'm going to tell you a little bit more about my book right now. So this is my book,
Fistful of Gold. You can see it's an encyclopedia distilling down my 45 plus years of prospecting experience plus my degree into the parts that you need to know. I spent most of 10 years writing this. It was not just a simple effort that, I sat down and wrote it. You can see it's like 250,000 words. It's not something you're going to read through in a day or maybe even a week or more. But it's got a lot of information and reference material that you can come back to. You can read it once and read it again and get more out of it because there's just that much depth of material in this. I wrote this book because I want you to have the skills to go out and find fistfuls of gold for yourself. And if you have the skills and know what you're doing and get out in the field and make a real effort, you can find significant gold. It's not easy. I'm not going to tell you that because, gold, it wouldn't be, close to $2,000 an ounce, which is what it is right now. It wouldn't be so expensive if it was easy to find. It's not easy. You just can't walk out into an old gold field and start picking up nuggets. If the gold was easy to see and find, the old timers would have picked it up and taken it themselves. So you got to have skill. You got to know what you're doing. You got to be able to master what it takes to find gold, and you've got to have the persistence and put in the effort to find the material, to find the gold or diamonds or gemstones that you're looking for. Now, this book has geology, it has facts about gold, it has stuff about diamonds and platinum, but it's mostly about gold deposits, how gold deposits form, how placer and nuggets form, all the questions you've probably wanted to ask. The book is available on Amazon, and I'll put a link to it in the description below, but you can look up on Amazon, Fistful of Gold, and by Chris Ralph, and find this book. Now, the book, if you look at it, it has a very high rating. It has like a 4.7 or 4.8 out of 5, which is really high. I mean, it's hard to please everybody, but I'm close to a 5 out of 5, not far from it, right? So it's been out. I've sold more than 15,000 copies of this book, and I've had tremendous response, tremendous positive response by the people who buy it. And I think if you buy it, you'll be just as happy with it. Now, in addition to my book, I also have a website that I do, and I'll tell you a little bit more about my website and show you some images from the website right now.
Now, my website is nevadaoutbackgems.com, and I'll put a link to the prospecting page, this prospecting encyclopedia page, down in the description below, but you can find it at Nevada Outback Gems. I sell some jewelry, turquoise, other gemstones there. I don't always keep the inventory perfectly up to date, so if you're interested in anything you see, do contact me first before trying to send me money or anything, because I want you to be able to get what you order. But the website has lots of different stories, old adventures, even some stories, true stories from the old-time miners of the 1800s. So I think it's something you'll find interesting.
The other thing I want to go back to is that all my comments, I want you guys to ask questions on the comments for my videos. I answer 100% of the comments that are made on my videos. Now, sometimes if somebody just says, hey, great video, I really enjoyed it, the comment may just be, well, I'm really glad you liked it. Or if it's a simple question. And sometimes I get people who ask me questions, I would take a book to answer that question. And I recommend that they just buy the book. But I answer all my questions. I try to help people as much as I can. I'm here to help you. So if you're interested in gaining the skills, if you're interested in knowing what you need to know to be successful, follow along with me. Subscribe to my channel, hit the bell so that they'll let you know when I come out with new videos, and I try to do that pretty much every Saturday morning. And you'll enjoy with me, you'll come along with me, we'll have an adventure together, and we will find some nice gold and see what it's really like getting out in the woods, or the deserts, or the mountains, wherever we land, wherever the gold is, wherever the diamonds are, wherever the platinum is. Come along, we'll have some fun. And I'll see you real soon on the next video.